In this video, we will learn the performance waterfall in Devtopia networking tab and how you can use it to diagnose your backend and improve the user experience on your web application. If you're interested in that at all, stay tuned. What's going on, guys? My name is Hussein, and if you're interested in the backend, that's what I discuss in this channel. So if you're interested, give that subscribe button and check out the other content in this channel. And how about we jump into it? All right, so what we're gonna do here is we're gonna do the waterfall performance in DevTools, and we're gonna inspect 3 websites, or maybe 4. We're gonna inspect example.com because that's the simplest site, unsecure site. Look how the waterfall looks like with a single resource, with a single HTML page, right? Without any encryption. And then we're going to do the same thing with encryption. And then finally, we're going to do a more complicated site with HTTP 1.1. And then finally, we'll go to my site, for example, HusseinNasser.com, where I use a quick. There are quick resources, protocols. There's HTTP 2 and HTTP 1. There's a mixture of stuff. So we're going to take a look at different websites and how each of them actually works and how the networking waterfall looks like for each of them. How about we jump into it? So what I'm going to do is go to http example.com and then hit enter. And I want to pay attention to these columns that we explained in another video with the DevTools, where we explained all these columns in the networking tab. Check out the video right here if you're interested to know that. But I want to pay attention to only the connection ID, the time it took, the remote address, the IP address and the port, protocol, and the resource. This is what we're interested in so far, right? I'm not interested in the method that is sent, like get or post. I'm not interested in cookies or anything like that. So now the waterfall is what we're going to look at. And when I click on this, there are a bunch of stuff. So how about we jump into all of them and then talk about them? So the first section is resource scheduling. So this is the browser, this is Chrome in this case that I'm using, and it is scheduling its CPU threads and the memory and all of that stuff, so it can serve you example.com going to this website. So that process took 5 milliseconds just to queue the result, right? And there's another section here called stalling. Before we actually do the connection, which is the TCP, SYN, SYN-ACK, and then ACK, which I talked about right here. Go check it out if you want to learn about the TCP handshake. Before we do that, we were stalled for any reason, right? We couldn't get another connection. Chrome was busy, or Chrome just decided, hey, let's not open a TCP connection. Let's wait for another connections to free up before we send our request. All of this kind of thing is under stalling. So we were stalled for 8 milliseconds, not that much. And then DNS lookup, it took us 13 microseconds to actually look up DNS. That's because probably DNS is cached for example.com, so it didn't take much. But if you're actually doing the DNS, you can actually take a look at that and see how long your DNS query is taking. So based on that, you can ask a lot of questions. Why did my DNS take this much? Right? So if something is slow, you just take a look at this, and wow, it's an X-ray of what is happening on your backend. Well, not really just backend, just front end and backend, which is beautiful for a full stack engineer, especially, right? But we're interested in the time that took here. This is where we're looking at. If you're in the backend, this is what you're looking at. Even in the backend, you have to look at this, like why establishing an initial connection, which is the TCP, took 9 milliseconds. 9 milliseconds is very fast. But if it's taking 100 milliseconds, like that means, or more, that means something is slowing the TCP connection to start. What is going on? Is it just the server so far is far, so that the SYN-ACK takes a long time latency wise, or your servers just have a lot of TCP connection and it's just pausing any new TCP connection, it doesn't accept any more connections, and it takes time to accept connection. That's another thing to look at. And when I say server here, it could be another reverse proxy, right? It doesn't have to be the final server. It could be Nginx, could be HA proxy, could be Caddy, anything. So now this is the initial connection. And then request response. It took us 62 microseconds to actually compile the GET request / and build the HTTP 1.1, because that's what we're using here, and then send it over. And then once we sent it, this is one of the most important things. Time to first byte. The moment I sent this request, I started sending this request and I finished sending it until I got the first byte of the response. That took 70 milliseconds. So that's called time to first byte. And you might say, why time to first byte? Why not just, hey, time to receive a whole response? Because you want to differentiate between the time the server actually sent you something and the time for the client to download that whole resource. So let's say you're downloading, I don't know, a movie, right? It's not fair to say, hey, the server took, I don't know, 3 minutes to actually give me the server, right? To give me that resource. Not really. Because how long did the server took to actually send you something? That's very critical because the response time, when you want to take a look at the response time, you took at the first byte sent from the server. And then anything after that is just you were downloading the content. It's called content download. So we want to differentiate between that, right? Because if this is long, that means the server is processing something, is doing something, right? But if this is low and this is a lot, and you're expecting this to be a lot, like you're downloading, I don't know, a picture that is very big and very high resolution, then yeah, it's gonna take a long time. I know that. I'm interested in this. This is the most interesting metric here. All right, so we looked at this, and then the moment we did that, Chrome made a request to favicon.ico, and that obviously took a little bit time to send that request, but we're not interested in that anyway. But that's the thing. We received this HTML. It was real fast. How about we spice things up? Let's do a secure connection. So I'm gonna do HTTPS example.com, and look how things are different now. So now what we're looking at is, again, you gotta take this with a grain of salt. Chrome does all sorts of caching and stuff like that, so it's gonna look a little bit different when it comes to here, right? So let me actually open a brand new incognito mode and do it all over again, so Chrome doesn't do all this stupid thing caching, right? So let's do it again with example.com. Look at this. Now you see. Look at this. Now you see it, right? So now we're going to port 443 because, well, it's HTTPS, right? That's the default port for a secure connection. And we're using HTTP2 in this case because ALPN during TLS handshake, the server decided to accept that and actually accept HTTP2. So let's communicate with HTTP2. So that's the different thing. And look at this. We have all sorts of colors now. Let's take a look. What is going on? So now queuing, not much. Stalled, not much. It didn't stall because guess what? There's nothing to stall. I am a new browser and everything is new. A single request. DNS took 12 milliseconds. So we did something this time. We had to go and fetch and ask for the IP address. What is my IP address for example.com? It took 12 milliseconds, not much. I'm using 1111 Cloudflares, so this is hitting my closest DNS server in California. So that's pretty fast, right? It's cached most probably. Initial connection took 52 milliseconds. All right, it's a little bit, I don't know. Okay, it's acceptable. I could go less for that, but yeah. SSL, which is TLS connection. Now we see this row. We did not see it in the previous explanation because it wasn't encrypted. Now it took 39 milliseconds, something to take about, just something to think about before we discuss. All right. And then request response, request send, and then time to first byte took 14 milliseconds. The same. The rest of the stuff is the same. All right. Let's spice things up a little bit. Let's go to a site that uses pure HTTP 1.1 and has a little bit more resources. And one of the sites I found is called badssl.com. When I hit badssl.com, boom, what happens? Look at all the stuff. Ooh, something beautiful happening here. We'll go through them. So the first request was a GET request to download the HTML page. And we download the HTML page. And then once we found the HTML page, we sent a fleet of requests to download the rest of resources that is available in the index.html. So that's what happened here. One request, look at this, one request. And then all of these are requests to download the rest of the files that is available in the index.js. So CSS, JavaScript, SVG, SVG, all this garbage. And look at this. All of them are in the same domain, are the same IP address. And here's the funky thing with HTTP 1.1. HTTP 1.1, all right, you can, and I talk about HTTP, guys, in general. Check out the video to learn more. But in a nutshell, HTTP 1.1, you can only send one request in a given TCP connection that you created. You cannot send two parallel requests on the same one. Why? Because we have no idea which request comes first and which response belongs to which request. We have no idea. We tried HTTP pipelining. It failed miserably with proxies. We have no idea how to do HTTP pipelining and multiple requests in the same connection with HTTP 1.1. That's why we invented HTTP 2. Talked about all of that stuff if you want to learn more. So what the browser do is says, hey, okay, I cannot send two requests, so that sucks. Let's establish 6 TCP connection. That's exactly what you're seeing. See this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That explains it, right? The browser has only 6 connections to that domain, and you better do all of that stuff, all the things that you download in the 6 TCP connections. That's why you see 1 and then brr, brr, brr. That's a scheduling problem. Becomes a scheduling problem. So now you, as a browser, are responsible to schedule these requests across these 6 TCP connections. So what happens? Let's go through this. Nothing fancy here. We do a DNS 59 millisecond, a little bit slower. So yeah. And then initial connection is like a little bit slow, 139. Wow. Okay. That tells me that the IP address is way farther than the example.com in that case, for my case in California. Right? So the SYN and the SYNAC and then ACK took a little bit longer than the case with example.com. So pay attention to this stuff. How far is your server? And then 76, that kind of scales nicely with the example.com. So slower, a little bit slower. So that's a single TCP connection. And you can see it in the connection ID, 86. That's connection 86. Once we got this connection back, right, we waited 64 milliseconds to receive the first byte. And then the content was just nothing. Basically, we downloaded the whole content. And now we figured out that we parsed the content. And once we parsed it, that's probably the time it took the browser to parse, right? See, from the time we finished downloading until the time we actually send the request, that's not measured by Waterfall because, hey, the browser did not make the request until it didn't make it immediately because why? It did not have a hint that it needs these resources. That's why early hints, the 103, I believe, that HTTP code and might help here. Says, hey, by the way, I'm gonna need this. HTTP 2 push is done. They removed it. The Chrome is removing HTTP push. So even if you want to push these resources to the server, to the client, you can't. They're removing this because nobody's using it. And I talked about HTTP 2 push, removing them from the protocol and the browser because it's not used. So yeah, look at this time. That's very interesting. This is the gap. So now, the browser decided to use the same TCP connection because now it's free. 86 is being used to download which file, which version. So I'm going to hide the protocol just so we can have a little bit more time. I don't need the time as well. I don't care because I'm interested in these puppies here. Index.css. So downloading index.css, right, on this 86 connection. And then also another CSS on the same connection, despite it. So it scheduled it on the same TCP connection. Obviously, it's queued, so it gotta wait. So it was waited and is queued at 320 millisecond. And look at this, it's stalled. Now it's stalled for 63 millisecond. Why? Because this puppy is being executed. This puppy is being downloaded, right? And this request index.js was scheduled on a brand new TCP connection 97. Well, brand new, I better see the initial connection and SSL. And there's a little bit stalling going on here too before we establish the TCP connection. Why? Probably a resources problem, right? And then this resource, funky.css, was also put on the same TCP connection, 86. So there will be a lot of stalling going on here too. But funky.js was put in a brand new TCP connection, 503. That explains, yeah, we have to open a new TCP connection. We have to do a TLS, right? And then Chrome.svg was put on the same TCP connection that we just opened, right? So that's a little bit stalling, but no, we don't have to open a connection. We don't have to take the hit to open a TCP connection. We just opened it. Now we have around, how many connections do we have? 3, 86, and 97. So 1, 2, 3 connection only. But the browsers then reschedules is another SVG file on 97, which already exists. So probably we don't have to open the connection. Can I do this here? Can I? Oh. All right. I guess I can't scroll. Can I scroll this down? Damn it. All right, I can't scroll. All right. So now this is VG connection, and then we're doing this on 97, already exists. We're doing the bad.svg on 86, which already exists. We're doing this on 09, right? 09 does not exist. I'm surprised. Look at this. And there is no TCP connection establishment. So where the heck did you bring 09 from? So that tells me there is either a bug in Chrome, DivTop, because here, look at this. Where the heck did you get 2509 from? It could be either a bug or the browser is actually caching. So it has an open TCP connection. It just didn't tell me because it's cached somehow, right? Because look at this, guys. 2509, we never opened 2509 before. So where did you bring this up from? If you open a new connection, you gotta tell me. So to me, there is a bug here. 2505, same exact thing. 2505. I don't see the initiation of the connection of 2505. Where the heck did you bring this up? But it's a brand new TCP connection, looks like it. All right. And then we're looking at this 66, same thing. 03 was already existing. And then look at this. We're just doing the same thing over and over again until we finish all resources. So that's why you see this pattern of so some recommendation to avoid this stalling that is happening. Look at these resources. These resources had to wait, poor thing, for all this to actually download. So a lot of people do before HTTP2, they did something called domain sharding, where they break up their domain, right? And stuff, badssl.com is going to be, I don't know, www.badssl.com and or server1.badssl.com, server2, server3.badssl. So they actually do different domains despite in the same IP address, right? But it will establish a different TCP connection in this case from the for the browser, so you can open many TCP connection on the same IP address essentially and streamline this, because we know the server can't handle this. But the right solution is to implement HTTP2, obviously, right? HTTP2, we don't have this problem. We open a single TCP connection and we can send as many as we want. Limit, there is a default limit, I think 200 streams. So that's 200 requests at a given time. I don't know why would you have 200 resources to download. That's just a lot. I would avoid that. But if you do, then HTTP2 is definitely your gal. All right. Final thing, let's open my website, which I'm using Blogspot, which is their Google services, right? So if I'm using Google services, and I want you to pay attention to this, I'm going to HTTP HusseinNasser.com. I want to make this slower. When I go to HTTP HusseinNasser.com, I'm gonna go to the insecure site, but Google will say, hey, don't go to that website, secure. Go redirect it to the secure site, and then there will be a sloth of resources after that. Let's watch. And let's stop. That's it. I don't want to, because the rest of the resources are not important. They're just ads, and no, I don't have ads. They're just pinging and logging and stuff like that. So let's take a look. Oh, this is interesting. So the first thing we did is we opened a 4410 connection, right? And this connection is, I need the protocol. I need to see the protocol. The protocol is HTTP 1.1, and it's on port 80. It's secure. We got it set. We did it DNS. We did an initial connection. Look at this. How fast is the TCP connection is. So fast. We got some results. We got some content. What's the content from this side? The content says, literally, it's just 226 bytes. And it says, what is the general? It says get moved permanently. Move to http www.hosseinnasser.com. So that's the first mistake, right? Go. I visited what? I visited hosseinnasser.com, not www, right? That's the same thing when you go to Google. It's the same thing happening, right? It's just my site. It says go to http www.hosseinnasser.com. So it does exactly that. So that's also unsecure. So it closes this TCP connection, opens a brand new one on a different IP, because www and hosseinnasser.com are completely different IP addresses. So now this opens another TCP connection, another one. DJ Khaled, look at this. Opens it, does a DNS. Why do we do a DNS? Because www.hosseinnasser.com is different than hosseinnasser.com. That could be different DNS queries. So it could be different IP addresses, like we just found. So now also go to port 80, because that's insecure, HTTP 1.1. But what does that give me? What does that give me? It tells me, dude, also moved permanently. Where did that move? Where did that move? It moved to HTTPS. So do you see how much work going on there? I know it's my website. It's just my fault. But I can't do anything about it because Google controls all that stuff. If it was actually I'm hosting my whole thing myself, hosseinnasser.com will serve the content directly, or it will immediately switch you to HTTPS, right? But there's two jumps. We open a TCP connection, we took a hit, open a closed TCP connection, and then we direct you to the wrong website. We also directed you to an insecure website. And then we had to do the same thing, and we also redirected you. Now we're doing an actual HTTPS. But let's take a look. Oh, now we're doing H2 because now it's a secure. ALPN decided to do, hey, all right, let's do security. Now we see a purple line here, SSL. It'll take a little bit more time to do that. Download the content. What does the content tell me? And the first content says 302. Isn't 302 also redirection? But it's a soft redirection because I want to redirect people to my about website, right? About link. So that just, hey, go ahead and redirect to this. It's in the same domain. So it's just a /p/about Hossein. So now I don't really need to close the TCP connection. I'm going to use the same one, 4422, to make another request to about Hossein, which returns 200. Okay. Now look at this. Any request to hosseinnasser.com goes through the same TCP connection. It just creates another stream. So now this is where you see the queuing. So it took us how long? It took us 500 milliseconds, half a second to actually get useful content. I try to avoid that. If you can avoid that half a second of closing an opening connection and redirection and just immediately serve the user with content, the backend, that's a backend fault. That's not a front end fault, right? The backend, the webmaster who configured this is just did not think this through, which is me, obviously. So now we're going to see a slew of requests of different resources here now. Blogger.com, which is Google's services, it's using, funny enough, it's using the same connection ID. I wouldn't trust this. How would you use the same connection ID on a different IP address, right? This is just weird. I wouldn't trust this. I think this is another bug because this is a different IP address. How would you use the same TCP connection? So, I wouldn't trust this. That's just a bug. So www.blogger.com, that's a different IP address. How would you use that? And it's a proof that we're opening a new TCP connection. So you're assigning it a new connection ID. There's a lot of bugs in DevTools, in my opinion. So there is a new TCP connection open, 4443, right? And we're asking resources.blogspot.com. So that makes sense. H2, all right? We open a TCP connection. And then anything to this resource, now we're going to use this connection. And then we're going to Blogger 4442 on H2. Blogspot 4532. What is this? There's also H2. Anything on Google, most of the time uses H2 or HTTP3, as we're gonna see. They're gonna do another requests. Some of them are stalling here. Some of them are getting queued because there are different TCP connection to different domains. If you can avoid this sharding that's happening, this ads or Google Analytics or all this stuff, that would be awesome. But now, look at this. I have Google user content. I mean, it's running on Google, so all of the stuff is just Google's stuff. Many TCP connection, despite being H2, that's an extremely wasteful thing in my opinion. H2 was designed to go to the same host. You can establish as many streams as you want. But if you're going against many hosts and using H2, the CPU usage on the client is gonna suffer as a result because H2 is not cheap. Look at this. Look at all this stuff. If you can avoid all that stuff, that would be awesome. But yeah, we're just opening, and downloading this request. Then we're going to YouTube, and this is our first quick connection. Look at this. Anything quick, you're gonna see 0 because I think this is something they're gonna change to null because there is no semantics of a connection, at least in quick as we speak, right? But they might. To me, there is a connection. There is a logical connection. It's quick, and I should see a unique connection ID, but I don't think a lot of people pay attention to this column. That's why there is a lot of bugs, as we can see. All right, so going, and all this stuff, quick. So we're doing a quick connection here, another quick connection. All of these to a different host, mind you, right? Some of them are the same host, like this YouTube. We're going to YouTube because I have a YouTube video in this channel, so in this content, so we're making requests to that. But it's getting scheduled, and look at this. There is a huge download of content download. Whatever, 500 milliseconds to download what? Google Ads. That's just weird. What did you download for 500 milliseconds? So yeah, guys. Look at this. That's what we're dealing with. So that's a complex site, but you can still read it. You can still see the stalling. So if you have a request, let's say something that didn't get served, pay attention to the waterfall. What caused it to take that long? If you can avoid this redirection, if you can avoid this expensive resource that is useless like this, we have two steps that we can eliminate immediately, right? You might not want to eliminate the first one because, first of all, if you use HSTS, which is something we talked about right here, you can hint to the browser that your website, you want to communicate with your website always with HTTPS so that it doesn't do this stupid redirection from HTTP. Because that means if I type HusseinNasser.com and I hit enter, it will automatically say, oh, Hussein Nasser, I spoke to this website before and it says I should communicate with it in HTTPS from now on. So if you can do that, the browser will automatically switch to HTTPS and you're going to get extreme performance as a result. You're not going to get this. You're not going to get this. You're immediately going to get this, right? So that's another trick you can do here. And all right, guys, I'm going to leave it at this for this video. Hope you learned a few things in this video. What I'm going to do is I'm going to start a series where I take different websites like YouTube and look at what is it doing and actually dive deep into all the stuff. Twitter, what is Twitter doing? What's YouTube doing? What's all that application doing? So if you're interested for that series, hit that like button and say, hey, show it, right? So we'll definitely do that. I'm going to see you in the next one. You guys stay awesome. Goodbye.